Q6605. What is dissymmetry of lift? A. The difference in lift that exists between the advancing blade half and the retreating blade half of the disk area. B. The difference in lift that exists between the rearward part and the forward part of the rotor disc during forward flight. C. A term used to differentiate between air flowing downward through the rotor in powered flight and upward through the rotor in autorotative flight. The correct answer is A. The difference in lift that exists between the advancing blade half and the retreating blade half of the disk area. Asymmetry of lift refers to the unequal lift distribution between the advancing blade half and the retreating blade half of the rotor disc. In a rotorcraft, the advancing blade is the blade that is moving in the direction of the rotor's rotation, while the retreating blade is moving opposite to the rotor's rotation. During forward flight, the advancing blade experiences higher relative airflow speed and generates more lift compared to the retreating blade. This is due to the combined effect of the rotational speed of the rotor and the forward speed of the aircraft. The advancing blade, with its higher airspeed, has a higher angle of attack and generates more lift, while the retreating blade, with its lower airspeed, has a lower angle of attack and generates less lift. The dissymmetry of lift creates an imbalance in the rotor system, resulting in a rolling moment that needs to be counteracted to maintain stable flight. Rotorcraft employ various mechanisms to mitigate this effect, including blade flapping, cyclic pitch control, and rotor design features. 6606. During forward cruising flight at constant airspeed and altitude, the individual rotor blades, when compared to each other, are operating at A. Unequal airspeed, equal angles of attack, and unequal lift moment. B. Unequal airspeed, unequal angles of attack, and equal lift moment. C. Constant airspeed, unequal angles of attack, and unequal lift moment. The correct answer is B. During forward cruising flight at a constant airspeed and altitude, the individual rotor blades, when compared to each other, are operating at unequal airspeed, unequal angles of attack, and equal lift moment. Unequal airspeed. As the rotor disc rotates, each rotor blade experiences different airspeeds. The advancing blade, which is moving in the direction of flight, experiences a higher airspeed than the retreating blade, which is moving against the direction of flight. This difference in airspeed is caused by the combined effect of the rotational speed of the rotor and the forward speed of the aircraft. Unequal angles of attack. Due to the unequal airspeed, the rotor blades will have different angles of attack. The advancing blade, with its higher airspeed, will have a higher angle of attack to generate sufficient lift. The retreating blade, with its lower airspeed, will have a lower angle of attack to maintain lift. Equal lift moment. Although the angles of attack and airspeeds are different for each rotor blade, the blades are designed to generate equal lift moments. This means that the total lift produced by the rotor system is balanced, resulting in a stable and level flight. Therefore, the correct answer is unequal airspeed, unequal angles of attack, and equal lift moment. 6616. When a rotorcraft transitions from straight and level flight into a 30 degrees bank while maintaining a constant altitude, the total lift force must A. Increase, and the load factor will decrease. B. Increase, and the load factor will increase. C. Remain constant, and the load factor will increase. The correct answer is B. When a rotorcraft transitions from straight and level flight into a 30 degrees bank while maintaining a constant altitude, the total lift force must increase, and the load factor will increase. In a bank turn, the lift force has two components: the vertical component that opposes gravity and supports the weight of the aircraft, and the horizontal component that provides the centripetal force necessary to maintain the curved flight path. As the rotorcraft enters a bank turn, the vertical component of lift must increase to counteract the increased centrifugal force caused by the turn. This increase in vertical lift is necessary to maintain a constant altitude. Additionally, The horizontal component of lift must also increase to provide the additional centripetal force required for the turn. This increase in horizontal lift helps the aircraft maintain the curved flight path. The load factor, which is the ratio of the total lift force to the weight of the aircraft, will also increase in a bank turn. The load factor is directly related to the total lift force. As the total lift force increases to support the increased vertical and horizontal components, the load factor also increases. Therefore, the correct answer is the total lift force must increase, and the load factor will increase. 6609. In certain single-rotor helicopters, the mast is rigged away from the vertical position by approximately 10. This slight vertical offset is primarily for the purpose of counteracting A. Yaw, B. Drift, C. Torque. The correct answer is B. In certain single-rotor helicopters, the mast is rigged away from the vertical position by approximately 10 degrees. This slight vertical offset is primarily for the purpose of counteracting drift. Drift is the tendency of the helicopter to be pushed sideways due to the influence of crosswinds or other lateral forces. When the helicopter is in forward flight, the main rotor generates a force called thrust that acts in the direction opposite to the helicopter's motion. This thrust force has a horizontal component that contributes to the forward movement and a vertical component that opposes the force of gravity. By rigging the mast away from the vertical position, the rotor system is tilted slightly forward. This tilt introduces a horizontal component to the rotor's thrust force, which helps counteract the sideways drift. The horizontal component of the thrust force works against the lateral forces, helping the helicopter maintain its intended flight path and counteract drift. It's important to note that the rigging of the mast is just one of several factors that contribute to the helicopter's ability to counteract drift. Other factors, such as cyclic control inputs and the helicopter's design characteristics, also play a role in maintaining lateral stability and countering drift. Therefore, the correct answer is the slight vertical offset of the mast helps to counteract drift. 6611. The tendency of a helicopter to drift in the direction of tail rotor thrust during a hover is called A. Coriolis force, B. Translating tendency, C. Transverse flow effect. The correct answer is B. The tendency of a helicopter to drift in the direction of tail rotor thrust during a hover is called translating tendency. Translating tendency occurs because the main rotor of a helicopter generates a torque that tends to rotate the fuselage in the opposite direction of the rotor blade's rotation. To counteract this torque and maintain a balanced hover, a tail rotor is used to provide an opposing thrust force. During a hover, the tail rotor generates a thrust that acts horizontally and perpendicular to the longitudinal axis of the helicopter. This horizontal thrust force creates a tendency for the helicopter to move laterally in the direction of the tail rotor thrust. The translating tendency can be explained by the combination of the horizontal tail rotor thrust and the helicopter's inherent stability characteristics. The lateral movement is a result of the unequal vertical forces acting on the fuselage due to the offset center of gravity and the tail rotor thrust. As a result, the helicopter drifts in the direction of the tail rotor thrust. It's important to note that other factors such as wind conditions, ground effect, and pilot inputs can also influence the helicopter's drift during a hover. However, translating tendency specifically refers to the lateral drift caused by the tail rotor thrust. Therefore, the correct answer is the tendency of a helicopter to drift in the direction of tail rotor thrust during a hover is called translating tendency.